Short lecture on proportional relationships equation. Make sure you have your notes ready to record this. We have the I can statement right here. You are going to learn how to write an equation in the form of y equals kx from a table or a graph. And to review what a proportional relationship is, that is a relationship between two equal ratios. For instance, if I have 4/5, that equals 8/10. That is a proportional relationship between 4/5 and 8/10. And we have this. So we can identify proportional relationships by the following. We can see an equation, and that equation is of the form y equals kx, where that k is the constant of proportionality. And if we need to find k, then what we would do is we would divide our y value by our x value. And I'll show you that in a moment. Here's our table. So in our table, we start with 0 for the x and 0 for the y. And each x value, we add 1, and each y value, we add 3. And what happens here is, I'll erase this, what we get is a relationship here. If we take 3 divided by 1, the y value of 3 divided by the x value of 1, and I have that up top here, so 3 divided by 1 is 3. So when we write our equation, it's y equals kx. K is 3, so our equation is y equals 3x for this relationship. And so to return to our equation, it's still y equals kx. And we have a graph. Now this graph is all proportional relationships make a straight line that start at the origin. And right here, that middle part right there is called the origin. It is the point 0, 0. 0 for the x. Now remember, this is the x-axis and the vertical line is the y-axis. And that's all related to this y and the x. So what we also have is this. So in this relationship, we take our y value, and I'll write this over here. We have a y value divided by an x value. So if I look in here, our y, the point right there, that is the point 1 on the x and 2 on the y. So the 1 on the x and 2 on the y. So when I have this, it's the y value is 2 and the x value is 1. And 2 divided by 1 is 2. So that's why this is working here. The equation for this proportional relationship on the graph is y equals 2x. And this is really saying that every y value is twice the size of every x value. What I could do is I can see, I'll do it in purple. So I have this point right here. Think about what the coordinates of that point is. Well, let me erase stuff here. I have some room here. So it is, 2 and 4. So 2 is the x value and 4 is the y value. And if I put this into y over x, to find that k, which is the constant of proportionality, I take 4 divided by 2, which is still 2. See, that's the constant of proportionality. No matter what y value you take, divided by any x value, you'll get 2. All right, so what are the characteristics of this? First, what we have is a straight line that goes through the origin. Okay, so a straight line going through the origin, check. It is linear, which means straight line. You should add that in there. The unit rate is 1 comma y. That's an important thing here. So returning to this, I'll do this in red. No, red's bad. Blue. So going back to this 1 comma y, well, 1 on the x, and then here, comma y. So that's 1 comma 2. That, if you remember before, that's 1 comma 2. And 2 is the unit rate. And the k, which is the constant of, oh boy, okay, of L, lost it, A-L-I-T-Y, snuck it in there. So that y value is the unit rate, it's the constant of proportionality, it's the k, it's a lot of stuff at 1 comma y. And the equations are in the form of y equals kx. And there you go.